What is a fact, as of yet, science has no explanation for? Story 1, Dark Matter Composition. Dark matter's exact nature remains elusive to scientific explanation. We've never observed it or been able to prove it exists. We just made a variable that helps balance the equations around galaxy rotation and such. Hilariously, it can't interact with light, so even if we had some, we wouldn't be able to see it. I wonder how much of astrophysics is just made up of variables we go, well, I hope this is real and roll with it. Dark matter is literally the observation that mass is missing, but we can't see what it is. You can't argue with an observation since it can be and is being repeated over and over. Moreover, this lack of mass has been observed across many scales, from galaxies to galaxy collisions and galaxy clusters, to even as far as the cosmic microwave background. If you want to hear it from an astrophysicist who actually studies the topic, Google "dark matter is not a theory" for a YouTube video. Story 2, the axis of evil in cosmology, and in general, the presence of galaxy superclusters, larger than the maximum size predicted by the Baryon Acoustic Oscillation (BO) model. One half of the sky is slightly warmer than another. There is no known physics that could cause this. The BAO model predicts that the largest structures in the universe should have a maximum size because they form from acoustic oscillations in primordial plasma, which was frozen in place by the expansion of the universe. This scale is Ekor 500 million light years, and yet there are lots of structures larger than this, including the entire sky itself. Story 3, the dual-slit experiment. Results. It is what it is. The double-slit experiment has always fascinated me, and I'll try to break it down in the simplest way that I can understand it, but it's still even confusing to me. Basically, you direct particles at a screen that shows where they end up. Between the particle emitter and the viewing screen, you have a wall that has two narrow slits cut out. Running the experiment with our understanding of classical physics, you would expect the pattern to look like this. This makes sense as the particle either hits the wall or goes through one of the slits. But in reality, you actually see a pattern like this. This is what we would expect from a wave such as light, where the brighter parts are the two waves, as each slit breaks the wave into another like this, interfere and overlap with each other. The time lapse of particles building up can be viewed here. Now, the really weird thing about this experiment is that when you try to detect which slit the individual particle passes through with the detector, you get the pattern we expect from classical physics, the two bands. So the question is, why are particles mirroring what we would expect from a wave only if we are actively not observing which state the particle is in? In other words, when we try to get information from which slit the particle passes through, the particle collapses its state into only one possibility. But when not observing, it exists in multiple possible endpoints. Story 4, consciousness. So far, we think it's an emergent property. As parts of the brain evolved, learned new things, and adapted new features, eventually consciousness emerged to handle and process all these resources. It allows living things to take a second and really think things through instead of relying on robotic instinct alone. With humans possessing so many evolutionary points invested in the brain's development, specifically emotions and problem solving, it's no wonder why human consciousness is the strongest. In other words, you are only conscious because your brain needs you there to function correctly. And if you didn't have all those fancy brain folds, your brain probably wouldn't need you to be aware this much, and you wouldn't exist. Story 5. There's something we've named the great attractor in the universe that is drawing all galaxies in our local group towards it. We have no idea what it is, but it has to have a mass that is unimaginable. The main reason we can't see it, it just so happens we're being pulled in the same direction we're facing the galactic core. Our galaxy is blocking the view. If we wait another 75,000 years or so, we'll be in a position where we can see what this structure is. Story 6. Things that exist as completely unique events. See, scientific analysis is about two things: repeatability and predictability. Will the sun come up tomorrow? It has every day in the past. Why wouldn't it continue in the future? In fact, we have extremely accurate predictions of when the sun appears. Discoveries that do not allow predictions, in fact, are not generally scientific. Singular events are those that are so rare that even when we've had evidence of it, it still happened only once that we can be sure of. Life, the Big Bang, the OMG particle. We can try to speculate, but the elements that cause things to work are extremely rare. It's funny though, in ninth grade biology, spontaneous generation was a theory that was historically disproven on the way to biological sciences, and yet they require spontaneous generation to occur at least once. And those aren't always the big, meaningful questions, but even the dumb, daily questions are beyond scientific discovery. If you asked your crush out, how would they respond? Scientific inquiry cannot help you answer the question. Only your crush can. There's no double-blind experimentation or 1,000 samples to experiment on, just one person, one answer. For the world, it doesn't matter, but for your world, it changes everything. Story 7, Sonoluminescence. Sonoluminescence was first discovered in 1934 at the University of Cologne. It occurs when a sound wave of sufficient intensity induces a gaseous cavity within a liquid to collapse quickly, emitting a burst of light. The phenomenon can be observed in stable single-bubble sonoluminescence, SBSL, and multi-bubble sonoluminescence, MBSL. In 1960, Peter Jarman proposed that sonoluminescence is thermal in origin and might arise from microshocks within collapsing cavities. Later experiments revealed that the temperature inside the bubble during SBSL could reach up to 12,000 kelvins. The exact mechanism behind sonoluminescence remains unknown, with various hypotheses including hotspot, Bremsstrahlung, and collision-induced radiation. Some researchers have even speculated that temperatures in sonoluminescing systems could reach millions of kelvins, potentially causing thermonuclear fusion. However, this idea has been met with skepticism by other researchers. The phenomenon has also been observed in nature, with the pistol shrimp being the first known instance of an animal producing light through sonoluminescence. Story 8, that whole bit about photons and observation. I am assuming you are referring to the idea that a photon acts like a wave when unobserved and a particle when observed. It's not really quite as spooky as it's often portrayed. Observation in this context does not mean literally looking with your eyeballs. If passively observing a particle, assuming we could even physically see it, somehow affected its state, that would be spooky. But that's not what happens. Instead, observation really just means an interaction with the particle in order to yield a measurement. We have to physically interact with the particle with some measuring apparatus in order to measure its state, example, its spin. And this interaction can affect this state. So it's not so much that the particle magically adjusts its behavior. When some conscious observer is looking in its general direction, as if it were aware it was being watched, it simply reacts to a physical stimulus according to the laws of physics, same as anything else. Story 9, a weird one, but atmospheric changes that cause joint pain in elderly people. There are a couple of very plausible theories with the knowledge to back it up, but science requires proof, and we can't acquire it. We can't observe these things happening in a controlled environment. Basically, lower pressure can cause irritation in sensitive nerves and tissues to swell slightly. Not enough for most people to notice. But when you have a knee on the cusp of severe osteoporosis, conditions may just be right for those things to make enough of a difference to actually feel it. Story 10, why only a small portion of the population, like me, have Rh negative blood. Everyone else is Rh positive. Only around 15% of the population has it. It doesn't show up anywhere in the historic records to pinpoint where it came from, how, from who, etc. And the highest concentration of Rh negative blood shows up in the Basque regions of northern Spain and southern France, where my maternal lineage is traced to. The reason it's important to even know about is because when an Rh negative female is pregnant potentially with an Rh positive fetus, her body will create antibodies to protect her from this foreign blood and body, leading to potential miscarriage, deformity, or jaundice after birth. Scientists created a shot given to Rh negative pregnant women called Rogam to prevent these issues, but they still have no clue why we have this issue. And if you didn't get the shot and your baby delivers healthy, there's an increased chance your next child will be miscarried, deformed, or jaundiced because your body carries those antibodies for life. I'm 47F and found that out recently when I tried donating blood plasma. Those antibodies are harmful to plasma recipients, but not harmful to me. My blood type is O negative, Rh negative, which means I can only receive that type in a blood transfusion too. Story 11, placebo effect. We know it's real, but we don't know how it works. Dark matter. There is something weird about gravity, but it may or may not be a new form of matter doing it. Naming the phenomenon dark matter kind of jumped the gun. They've been looking since the 90s, with increasingly sensitive detectors, and so far haven't detected a single particle of the so-called matter, Earth's magnetic field. There is some hand-waving about molten magma circulating around an iron core in a double dynamo, but no one has ever modeled exactly how any of that creates a magnetic field. Story 12, Wave and Particle, Double-Split Experiment. Observing matter and light makes it act completely differently. It's like saying if you spin the roulette wheel and watch it, it is 50-50 like you'd expect. But if you turn around while it's spinning, it's always red. The best explanation I've heard is that we live in a computer simulation, i.e., if you are playing video games, a first-person shooter, the bad guy isn't in the room until you walk in there. It's not like they waste all that processing power to have all the bad guys in every room on the map. It is only once he is observed that he exists. Maybe simpler, the entire map doesn't even exist until you load it. It's not like all the maps are always playing in the system and you hop in. So basically, everything unobserved is a wave. And then when it is observed, it acts like a particle, like we are used to seeing in classic Newtonian physics. Story 13, Placebo effect and medical hypnosis. We know they are there. We know they work and are able to use them, but the research to the exact how and why they do isn't completed. No, I don't believe in magical healing properties, nor mind over matter, timey-wimey stuff. I'm fascinated by the fact that our brain can shape the perception of our surroundings and ourselves to an extent where we have to test against that perception. I myself am, despite not being a psychologist of any kind, in a psychology context. And so I'm confronted from time to time with these things and get a glimpse of what it could matter for us to understand perception and the means of psychological diseases. Hence why I've mentioned placebo and hypnosis together and formulated the advancement of the science behind rather vaguely, because I myself am not a scientist in this, and just replicate what my peers reference to me. Story 14, there's a whole lot we don't understand about physics. We don't know why any of the fundamental forces exist. Strong nuclear force, electromagnetism, etc. We know how they work, and we can accurately measure how they work. But we don't know why positive things attract negative things, or why the strong nuclear force brings things together, or why gravity brings things together. They just do. We don't know why quantum tunneling works, we just can measure its likelihood of happening. Story 15, Abiogenesis, How Life Began. Kind of a big one. We have a pretty solid guess. The RNA world theory is the most supported. So let's think about the three main building blocks of life: proteins, DNA, and RNA. Proteins are amazing at doing things. They're catalytic and drive chemical reactions. DNA stores information. It's very stable and non-reactive. RNA has catalytic activity, but it's nowhere near as efficient as proteins. It also stores DNA, but it doesn't have the double helix structure to keep it stable. For a long time, scientists thought that the protein world theory must be true. Proteins are amazing and do so many things. Naturally, we evolved from proteins, and we spent a lot of time looking for proteins and amino acid precursors. You're probably familiar with the Miller-Urey experiment, where really just Urey. Miller was just the principal investigator of the lab, but Urey did this experiment, took a hypothesized early Earth atmosphere and injected it with energy, electricity, and the result was amino acid precursors. This experiment was actually what Urey ended up doing for the rest of his life. They managed to get amino acid precursors from any form of energy they applied, even sound waves. So theoretically, the primordial ocean could have eventually been a soup of proteins, and that led to life. However, there's a problem. Even if you have a ton of incredibly complex proteins together, how do you pass down that information? After all, you must pass down information to have life and evolution. Story 16. Here's one thing that I don't think that anyone has said yet: turbulence. Something seemingly so simple and all around us, no one really bothers to take a deeper look. We know that it is caused by a difference in kinetic energy in parts of a fluid flow, and yet we can only really offer basic predictions and calculations. Richard Feynman even describes it as the most important unsolved problem in classical physics. We do not really know how to predict it, and many hypotheses and calculations have been made. Yet scientists are still working on this seemingly simple problem. Story 17. We all know that gravity from the moon causes tides, Earth's gravity holds us to the surface, and the sun's gravity keeps our planet in orbit. But how much do we really understand it? This powerful force is generated from matter, and more massive objects therefore have a greater ability to attract other objects. While scientists do understand a great deal about how gravity acts, they aren't really sure why it exists. Why are atoms mostly empty space? Why is the force that holds atoms together different from gravity? Is gravity actually a particle? These are answers that we really just can't answer with our current understanding of physics. Story 18, genetics. When you dig into it, there is so much left to know. Fascinating, though. Oh, yeah. Next to nothing works as simply as it was presented in junior high. Less, this one gene does this one thing, and more, these 6 genes all play a role to varying degrees. And that may change completely if you have this other unrelated gene and all that can be thrown out the window in the presence of these epigenetic factors. And even if we understand all that, sometimes it just doesn't end up working like the signs said they should. And that's just if we're talking about something simple like hair color. Story 19 didn't see this, so hopefully not a repeat. The optimal human diet. Up until recently, sugar was accepted as bad, but not terrible. Fat was vilified. Sugar is now being linked to, as far as I know, essentially all of the autoimmune diseases. The accepted amount of sugar in a diet was way too high. There's evidence of big sugar skewing studies that cause the vilifying of fat. Also, the impact of diet and autoimmune diseases. My sister had 2 autoimmune diseases. She had a terrible diet her whole life. Read, processed foods were a staple. Long story short, doctors kept telling her to eat what made her feel comfortable. She kept getting worse and died before she turned 30. You could also point this at overdosing of narcotics, but her dosage was cut back significantly for about a year before she passed. But the diet thing baffled me, and I wish I had pushed her more to eat better when I had the chance. Well, this just got more personal than I anticipated. Basically, we still don't know what the optimum proportion of each food base we need. And we're finally finding out that we should just eat real food, even if it's higher in fat. Looking at you 1990s and all the gross fat and sugar alternatives. Story 20, just imagine someone right now probably has a theory that can just about cover all this, from black holes to dark matter and energy, dreams and deja vu and consciousness, even the paranormal like ghosts and psychic abilities, and other things like the reason behind the polarization of light, light's wave and particle duality, quantum spin, the reason how and why light is constant, and exactly why it is the constant speed that it is. This theory would have implications even the author wouldn't be able to begin to comprehend. The true reason behind why we need to sleep, and when or if that is cracked, our understanding of conditions like SIDS and ALS will make huge progressions. And just imagine the person who has this theory probably can't find anyone to listen to. Story 21, I'm a mechanical engineer and I'm amazed we haven't fully calculated flow. Flow of anything, wind, water, etc. This is why the weather is unpredictable. It's called the butterfly effect. Butterfly effect means a butterfly could flap its wings in Australia and affect me in the United States. It's unpredictable. Even better, we can't predict simple flow, such as through an HVAC duct. It is modeled and modeled very accurately of what the expectations are, but it's never fully accurate. It's amazing. And these models require insane computing power. Story 22, the answer to every question is entropy. The Big Bang was the beginning of it. Things were going well. The state of it was singular. Now it isn't. Crap's flying away faster and faster. A living organism is a pure example of the chaos it causes. It makes no sense to make something as messed up as the Kardashians when remaining inert chains of carbon was so much easier. I'm guessing 0 degrees Kelvin is the only state where the universe could regain singularity. But we have a long time before that happens. So until we figure it out, which might be the whole point of biological life, to derive the truth of it all, we get to sit around and mind screw each other. Theory. Aging and dying and reproducing gives evolution a chance to keep things adapting. When technology surpasses evolution, we'll be left with people who will spend thousands of years thinking this crap through. Or we get wiped out by a space rock and hope the homies out in some other system are working the problem too. We've pretty much gained telepathy through technology. What other senses could we acquire? Story 23, dark matter, dark energy, big portions of quantum physics, subatomic particles and all of their properties, black holes and singularities, the so-called empty space, why space is constantly expanding, the stuff beyond our observable universe. What caused the Big Bang? Did the Big Bang even happen like how we envisioned it? Tons of unsolved mysteries. It's fun to think about the great beyond and what's all above us, but we don't really have to go far from home to see that mysteries are scattered throughout our world. Questions such as when or how did tectonic plates start? What's really hidden under the Earth's crust? If life could exist down below, how did life start on Earth if non-carbon-based life exists? Methane, silicon, etc. And tons of biological wonders. In fact, some of the greatest mysteries in science sit right in your head. What is consciousness? What is self-awareness and free will? What could our brain achieve if it could evolve even further? What is true reality and how is our perception different from true reality? Story 24, a microscopic understanding of friction. The Cosmon paradox. Entropy is a measure of disorder in a material. Crystalline solids therefore have a relatively low entropy because the molecules it comprises are very regularly arranged. Meanwhile, a liquid of the same material has a higher entropy because the molecules are disordered. Also, you can cool a liquid below the freezing point without the material actually freezing. This is called supercooling. If you measure the entropy of pretty much any supercooled liquid and then extrapolate the results to lower temperature, you find a point where the still disordered liquid would have a lower entropy than the ordered solid, a paradox. However, when you actually try to supercool the liquid to this temperature to observe this, something happens first. The liquid becomes a glass, and the entropy stops changing with temperature. So the glass transition prevents this paradox from actually happening. But we have no detailed explanation of how liquids transition from liquid to glass, the way we do for how liquids transition into a solid or a gas. 3. How anesthesia works. Story 25. The true cause of Alzheimer's disease. Don't get me wrong, there are many theories, such as the degradation of the blood-brain barrier, or the buildup of tau proteins or other proteins. Once we figure this out, we can begin to find a cure. Worked in a lab last year looking at thousands of different drugs to see their effects on the brain and these proteins. There are a couple of promising drugs that have the effects we were looking for. Maybe one day, within the next decade or so, we will finally find a cure or more effective treatments. Recent research points to P. gingivalis infection in the brain. It's the same bacteria that caused gum disease. This hypothesis is looking pretty strong, and it fits with all the stuff we already know about inflammation, the blood-brain barrier, and beta amyloid plaques being involved in Alzheimer's.